In this flip, we will review redox reactions, oxidation and reduction reactions, and also review oxidation numbers. You covered this topic in general chemistry, so hopefully it will all look very familiar. One can remember the exact definition of oxidation and reduction, such as oxidation is the loss of one or more electrons by a substance, whether element, compound, or ion. Its increase in positive charge. It occurs to the reducing agent. Reduction is the gain of one or more electrons by a substance, whether element, compound, or ion. Its increase in its negative charge, and it occurs to the oxidizing agent. Or you can remember Leo gear or oil rig shortcuts. It might be childish, but this is how I still remember this for the last 20 years, and I personally prefer Leo gear. Leo gear. Leo stands for losing electrons, oxidation, and gear, gaining electrons, reduction. Or oil rig. Oxidation is losing, reduction is gaining. Let's review oxidation number or state, which is the value that indicates whether an atom is neutral, electron-rich, or electron-poor. There are a few rules that one needs to keep in mind. An atom in its elemental state has an oxidation number of 0, for example, Na, H2, Br2, etc. An atom in a monatomic ion has an oxidation number identical to its charge. For example, Na plus is +1, Ca2 plus +2, etc. An atom in a polyatomic ion or in a molecular compound usually has the same oxidation number it would have if it were a monatomic ion. Hydrogen can be either +1 or -1. Oxygen usually has an oxidation number of -2, but as you can see, it can be also -1 or others. Halogens usually have an oxidation number of -1, but sometimes they can have different numbers. The sum of the oxidation numbers is 0 for a neutral compound and is equal to the net charge for a polyatomic ion. For example, H2SO4. Let's calculate oxidation number of S. They have two hydrogens with +1 charge, plus X for the charge of sulfur, and +3 oxygens with the -2 charge. Since the whole thing equals to 0, it's neutral, X equals +4. Pause this video, calculate oxidation state for chromium in the anion below, and compare the answers. The last thing we need to review is the concept of reducing and oxidizing agent. Reducing agent causes reduction. It loses one or more electrons, it undergoes oxidation, and oxidation number of an atom increases. While oxidizing agent causes oxidation. It gains one or more electrons, undergoes reduction, and oxidation number of atom decreases. So let's look at this example. Fe solid plus oxygen produces rust, Fe2O3. Since Fe is in elemental form, its oxidation number is 0. Oxygen is also in its elemental state, thus its oxidation number is also 0. In Fe2O3, oxidation number of oxygen is -2, thus we can calculate the oxidation number of iron, which is +3. Fe goes from 0 to +3, which means it lost 3 electrons. Losing electrons means oxidation, thus iron is going through oxidation. Oxygen went from 0 to -2, it gained 2 electrons, thus reduction. Since Fe is going through oxidation, it is a reducing agent. And since oxygen is going through reduction, it is an oxidizing agent. In this flip, we reviewed redox reactions, oxidation numbers, and discussed reducing and oxidizing agents.